Hello, I'm Mr. McBrien. This is limiting reagents and percent yield. So today I'm going to take up a question that was requested previously, do a quick overview of the lab, then we'll do our experiments and do some practice. Okay, so my homework. If we have a 100-gram sample and we've determined that 35.9 grams is aluminum and 64.1 grams is sulfur, what's the empirical formula for the compound? So to solve this problem, we can use the handy new document camera. Reviewing, we have 35.9 grams of aluminum, 64.1 grams of sulfur, and we want to know the formula. So we'll need the mass of a mole of aluminum and the mass of a mole of sulfur. Using these, we can solve for the number of moles of aluminum moles comes up to the top. We get 1.33 moles of aluminum. For the sulfur, 64.1 grams of sulfur divided by 32.07 grams per mole equals just about 2 moles of sulfur. And then from there, this essentially gives us the number of molecules, of course, and we, of course, divide by the smaller number. 1.33 over 1.33, of course, gives us 1. And 1.99 over 1.33 is just about exactly 1.5. So, for every mole of aluminum, we have 1.5 moles of sulfur. Now we need to get those to unit. So, of course, we can examine C the 0.5, multiply both by 2, and get 2 aluminum to 3 sulfur. And this means that our formula is Al2S3. Our formula is, again, Al2S3. And we're done. Okay, so let's move on now to talk for a few minutes about our limiting reagent lab. So today we're going to react aluminum with copper chloride to produce copper and aluminum chloride in aqueous form. So a few hints. It's a good idea to put your equipment together before you start your reaction. Make sure you've got everything that you need before you start. Now, it's easier to determine your weight by tearing the balance with the paper on it. If you don't know how to do this, please be sure and ask for some help. But essentially, we're assigning the paper, and effectively we're giving telling the balance how much the paper weighs in order to just weigh the material that we're weighing. There's going to be waiting time here. Be sure and spend that time working on problems and getting your lab write-up together. Don't waste the time while you're waiting for the reaction to proceed. Okay, calculating percent yield. We've talked about this previously, but maybe a few hints to make sure that we stay on track. The first is remember to apply the stoichiometry before comparing the number of moles of reactants. Next, don't try to calculate the yield before you establish the limiting reagent. There's no point to doing that calculation until you figure out the limiting reagent in your reaction. So, a little flow chart to walk us through the calculation. First off, we make sure that the equation is balanced. Next, we collect the molar masses for all of the reactants. Then we go through our big calculation to find the limiting reagent. Once we've done that, we can calculate the theoretical yield, and we compare the actual yield to the theoretical yield in order to establish our percent yield. Okay, an example calculation. So let's take this example from previously. Calcium oxides are limiting reagent, and so the reaction in our case previously would produce 44.3 grams of calcium carbonate. So we can calculate the percent yield if we got 33.1 grams of calcium carbonate, and we were supposed to get 44.3 grams. We multiply by 100%, and we get our percent yield of 74.7%. It's a pretty straightforward calculation. For your homework, please practice building your stoichiometry terms and work on the limiting reagents and yield in the limiting reagent worksheet and in the textbook on page 319 in the numbers and 321 in the numbers shown. Thanks for listening.